Our next speaker is Andrew Hacker, who is the president of MistIQ Technologies. Andrew is also a professor at the Harrisburg University. He's the founder of the Thought Network in the world, which is the world's first public artificial intelligence blockchain. Thought is based on individual pieces of hybrid data or artificial intelligence known as smart data that create a whole new paradigm of ground up AI. Andrew is the former Deputy Chief Information Security Officer for the Commonwealth of Pennsylvania, where for years he supported the Enterprise Information Security Office in managing information security, guiding state agency CISOs and executives, interacting with state and federal partners, and protecting citizen data and government systems and operations. He has publications in Network World, Information Week, HelpNet Security, and appears regularly as cybersecurity expert on Fox, NBC, and CBS news affiliates locally and nationally. So please help me welcome Andrew Hacker.
Thank you very much, Eric. Is my mic on? Yeah, okay, good. Thank you. Okay, cool. Good afternoon, everybody. Can you guys hear me okay in the back? Great. So I am distinguished and lucky in the fact that I get to speak with you guys after lunch. So you guys all look, nice and alert, and I think we should be in good shape. The good thing is cybersecurity is always a very fun topic. There's a lot of interesting things that happen in cybersecurity. So today what we're going to talk about is basically cybersecurity in the realm of information technology systems and automated vehicle and connected vehicle systems, and basically how the digital explosion has affected cybersecurity in both positive and also potentially negative ways. So one of the big things that we always hear with technology today is sort of this technology explosion. And there was many references to that today. Everybody's kind of familiar with that hockey puck of things look kind of normal for a while, and then all of a sudden things kind of take off. So, there are a lot of different technologies that are converging today. Artificial intelligence, they've been talking about the promise of artificial intelligence since the 1950s, right? 1960s and 70s, it didn't quite happen. 1980s, there was a lot of research that happened, and then, nothing for another decade or so, right? So, even in artificial intelligence, what's been happening now is actually quite amazing. How many of you have been talking about something, relatively near to a device that might have some kind of natural language processing, such as your Android device, or maybe you have Google Home or Amazon Echo, right? And gone and searched on Google, and did the autocomplete ever, complete what you were saying? Okay, well, this happened to me. My wife and I were actually watching a movie, and there was some scene where a helicopter flew from the West Coast all the way to Washington, D.C. And my wife and I were kind of discussing it and saying, well, that doesn't seem quite right. It was a smallish helicopter, and, figuring with the amount of gas that was in that helicopter, probably couldn't have gone more than, 500 miles, let's say, right? So we said, wonder what is the range of a helicopter? So my wife says, oh, okay, well, let me go ask Google. Pulls up her phone, starts typing in what is the, and the autocomplete said range of a helicopter. And this was last year. And I was, kind of in disbelief. I said, that can't be possible. And, you might say, well, coincidence, maybe there was, something else that might have happened, or some other search that you might have done that, Google's algorithms might have, drawn that conclusion. But, in fact, over the last 6 months or so, it's become a thing, right? Even to the point where, these major companies have said, well, we don't do that, right? But, the technology's there. Beating chess championships, and how many of you know what the game Go is? Okay, so Go is like chess, but it's, let's say, 1 million times more complex. It's black and white stones, and you try to capture the board. So, AI beat chess back 20 years ago, chess champion Kasparov, and just recently, beat some of the greatest grandmasters in Go, a couple of years ago, and it was hugely significant. So, another big trend that's happening now, Internet of Things. devices getting smaller, computing power getting, much more powerful. We've got quad and 8-core processors, here in these phones, right? How many sensors are in these phones? Yeah. Do we know? 15, 20 different sensors, accelerometers, GPS, right? All kinds of communication. Pretty much now with the size of computers going down, but also the cost of computers going down significantly. We can have a computer, the size of a stamp or smaller, right, with quad core in it, maybe, half a gig of RAM, some kind of wireless connection, whether it's Wi-Fi, near-field communications, or Bluetooth, right? And some of these devices could be in the $1 to $2 range, right? And if you follow the progression of that, soon they're going to be 10 cents, 20 cents for one of these little computers. That pretty much means that we can embed a computer in almost anything, right? Shoes, clothes, phones, eyeglasses, even start to think about, computers being embedded into, biological pieces, right? Lenses, contact lenses that would, have screens that overlay. I mean, they're already working on that. That'll happen soon. And one of the things that happens with all of these different technologies and their convergence is really the amount of data that gets produced by all of these devices and all of these technologies is huge. We already heard today, one flight of an airplane, 1 terabyte worth of data. It's probably more than that. How much data does, your average vehicle today that was, created in the last 2 or 3 years produce? Maybe it's a terabyte an hour. Where does all that data go, right? Does it just get deleted? Does it sit on a hard drive somewhere? Does it get transmitted somewhere? So, basically the digitization of everything, creates a whole new paradigm. Connectedness, even just general connectedness. If you think about how many different devices we're talking about here, there was a great program I saw. It's actually on Netflix. It's called Lo and Behold, and it's about sort of the history of the internet and where technology is going. And one of the interesting things was they found some closet in, one of the California universities that, had brooms in there, and there was a, big mainframe-ish type device that sat there, and somebody actually looked at it and figured out what it was. It was node number 1 of the internet, right? And they kind of walk you through how, this device, when they first had that started, and then they connected to UC Berkeley, they had node number 2, and how when they did the connection, they actually had to pick up the phone, right? And they had a terminal. So this is the, first communication over the internet ever. It was supposed to be login, log in, right? So they're on the phone, and the gentleman who was one of the original team there said, I said, I'm sending the L. Did you get the L? Yes. I'm sending the O. Did you get the O? Yes. And then node number 2 crashed, right? So that's why it's called Lo and Behold, because the first message that was ever sent on the internet was LO, right? So that's 2 nodes, and then they talked about, then there's 10, then there's 100, then there's 1,000, right? And the interconnectivity between all of those devices, if it's not managed, can get kind of crazy. So, that's going to be one of the big challenges for connected vehicles, because there's going to be so many different types of connections that vehicle might participate in, right? So, basically, this leads to a whole new ecosystem, right, in transportation. So V2X, or vehicle to everything, we talked about vehicle to vehicle, vehicle to infrastructure. There's lots of other, types of different connectivity types that are spawning up. And, with any ecosystem, there's all kinds of competition from different companies that say, okay, well, we're going to try doing this, and we'll try doing this. So just to kind of lay out some of these, vehicle to infrastructure, where this vehicle's talking to roadside units, or, any other sensors that might be part of the general transportation infrastructure. Vehicle to vehicle, obviously, we've talked about a lot today. Vehicle to pedestrian, okay? So in the case of somebody walking a dog or something like that, maybe the vehicle can actually have some kind of communication with a device that pedestrian has, right? Vehicle to network generally, are we accessing the internet from the vehicle? So all of these different types of connectivity and all this complexity, one of the things as a cybersecurity person that we're very used to is complexity, right? And complexity in general is sort of the opposite of cybersecurity, or it's, the nemesis of cybersecurity, because, in cybersecurity we try to keep things simpler. We try to, reduce variables, because the more complexity we have, the harder it is to secure what we want to secure, right? So, just some general cybersecurity concerns, and there's always a lot of different cybersecurity concerns in any complex system. But just to kind of give you an idea, what if somebody breaks into a car and takes over the tracking system and can track a person wherever they go, right? If they break into the car, and if your phone is connected to that car, most likely that person could get into your phone, maybe pull your contacts, right? They could track where you go. It's almost like Facebook. You don't put your location everywhere you go on Facebook, right? You wouldn't want your children to put, hey, I'm at the movie theater today on Facebook, right? Because then everybody knows where your child is. So, those kind of things can be, used in a very negative way. Identity protection. What kind of data is this system that is me with respect to this vehicle telling everybody else, right? And who's actually, who's getting access to that data and what are they doing with it? Everybody's, heard everything about, Facebook and Cambridge Analytics, and, the fact that Facebook was basically saying to these analytics firms, hey, take all of this user's data. Not only this user, but all this user's connected friends or people, right? I mean, we might be getting a little desensitized to the fact that everybody has access to all of our data all the time, right? I mean, there was, this isn't new. This has been happening for years with lots of different companies. And generally speaking, everybody seems to be okay with that, right? And they shouldn't necessarily be. Most people I talk to, well, Facebook's reading all that stuff, and their response is basically, well, I'm not doing anything wrong, so it's okay, right? But really the problems come down to, well, what happens if someone else grabs that data, right? They can do all kinds of really bad stuff with that. So, privacy and identity protection, very big piece. And sure, anything to do with safety. We saw all those trucks in Wyoming piling on. Well, that was snow and bad weather. But think about it if it was a bad actor saying, oh, hey, watch me take this truck here and flip it on its side on an 80 mile per hour highway, right? You could think about the catastrophic types of damage that affecting these systems could cause, right? And the more dependence we have on the automated systems, right? This is why I said there's a good side to this and also potentially bad side. The more reliance, the more dependence that we have on these things, the more impactful and greater, negative risks that we have when something bad happens, right? And if you think about just the general line of physical to digital, right? Physical back in the old days, I work on cars. I haven't done it recently, but I love to pull things apart and hopefully get them all back together. I took a motorcycle apart once, put it back together. I still had a bucket of nuts and bolts, and so that's probably not a good thing. But generally speaking, back then everything was physical, right? You pressed on the accelerator, there was a cable. You pulled a choke out, which would make the gas richer, right? So that would start in the cold weather. Steering, metal, gears, good to go, right? Well, it's funny, the first time I actually realized that my car now is a 2016 vehicle, that I realized that it was electronic steering, right? And how I knew? Because I can feel it. When you're in a physical system, analog system, it's generally smooth, right? But my car was actually doing little nudges, right? And then I looked it up, and in fact, the vehicles today, I'm not sure what year they started, but there's electronic components to it, and sure, eventually there's a physical thing that ties to the wheels, right? But that steering is controllable. So if someone breaks into a car, you can get at that. So just another slide about V2X. This is interesting because it kind of expands on the connectivity piece, right? So we talk about pedestrians, even grid, right? Car connecting to grid, all kinds of possibilities here. The charge is low, the energy is more economical here at this space, so the autonomous vehicle can drive there. V2H, your home, right? Home automation systems, one of the most vulnerable from a cybersecurity perspective technologies going today, right? Nest, you've got thermostats that are, you can manage by phone. If you can manage it by your phone, chances are you can break into it, right? So in general, V2X and any kind of automated technology in transportation is kind of trying to change the mindset from basically reducing injury and fatalities to kind of avoiding them, right? So, collision avoidance systems, increase in communication so we can transmit information about what's happening. We talked about situational awareness and real-time type systems, okay? So this should overall increase driver safety, potentially decrease traffic, right? So if we have real-time traffic knowledge about our surroundings, right, whether it's from some service or from other vehicles, we can route traffic around accidents, things like that, right? Could increase fuel efficiency. All kinds of numbers of ways. Maybe it's platooning, maybe it's reducing the terrain of the route that you go, right? So let me show you something interesting here. I think you guys will get a kick out of this. So there are a couple of researchers here that have famous,
like many thousands of Jeeps.
Greenberg, senior writer at Wired, allowed two hackers to remotely control a 2014 Jeep Grand Cherokee that they say hadn't been altered in any way while driving on a highway in St. Louis.
So first we're going to turn the fan on him.
Yeah, let's turn the fan on, see if he even notices. All right, something just turned on, all the fans and AC and stuff. I didn't do that.
Uh-oh. Somebody hacked my video? No, I embedded this. Playback error. Well, if you guys don't mind.
The Hyundai Epic Summer Sales Event.
Sorry about the ad.
This summer is going to be epic. Lease an all.
Let's try it again.
Like many thousands of Jeeps around the world, it can be remotely hacked over the internet through a cellular connection to its entertainment system.
Andy Greenberg, senior writer at Wired, allowed two hackers to remotely control a 2014 Jeep Grand Cherokee that they say hadn't been altered in any way while driving on a highway in St. Louis.
So first we're going to turn the fan on him.
Yeah, let's turn the fan on, see if he even notices. All right, something just turned on, all the fans and AC and stuff. I didn't do that. Now the air conditioning is blasting, the music is blasting, and I can't see anything because of the windshield wiper fluid.
Hackers Charlie and Chris say they worked for the last year to develop the software to take over the digital systems in the vehicle.
So we're killing the engine right now.
It says park, it says... I turned on my hazard lights, but I was still stuck in the right lane with no shoulder to escape onto. Guys, I'm stuck on the highway.
What did he say?
I don't know, I think he's panicking.
They say this experiment was done to show how some late-model Chrysler vehicles could be exposed to hacks through an internet-connected computer in the dashboard.
We wanted to show that this attack has serious consequences for this vehicle.
We're only two guys with one car, right? So, we can't look at every car, and we want to release this information because more people like us need to be focused on this problem.
Charlie and Chris alerted Chrysler, who is offering a security update at no cost to customers. They released a statement writing, similar to a smartphone or tablet, vehicle software can require updates for improved security protection to reduce the potential risk of unauthorized and unlawful access to vehicle systems. Be sure to watch Inside Edition.
Okay, yeah, and actually, I guess this video here didn't show there's a couple more pieces that I wanted to show you.
The Gum Collection from
over
Crest.
The internet.
My gums are irritated.
Sorry about that.
I don't have to worry about that. Do I?
Actually, you do. Harmful bacteria lurk just below the gum.
Isn't Google gracious that they just love to just keep sending me content? Okay, slideshow. So, yeah, and they show at the end, basically they can control the brakes. So, they show the Jeep kind of just rolling off a parking lot down into a ditch. So, the good thing is, and Brian from Gannett Fleming pointed out that, he had a similar vehicle and, they were quick to update the patch. But, think about the fact that they had to do that. Now we're patching our cars. We used to be, okay, well, I'm patching my Windows 95 system, right? And that's a huge thing. And, our phones kind of update themselves, somewhat periodically, but we don't really think about that so much. But patching vehicles, right, and patching the software in vehicles, that's a pretty big deal. So the key point here is that, as these systems get more complex, right, there's a lot of different and, multiple ways to break into these devices. So just to kind of give you an idea of all the different connection points, and, this is just a representation, there's more, right? So, think about, tire pressure management system, your remote keyless entry. Now they're doing that by cell phones too, right? Bluetooth, in-car applications, right? Google and Apple both have auto-related applications, right? Telematics, cellular, right? Almost every car today has all of these connections. Cars now even have Wi-Fi hotspots. Cars have Wi-Fi clients that connect to your home Wi-Fi, right? What about insurance dongles, right? Insurance being such a huge part of all of this connected vehicle new explosion. They want that data. They want to be able to tell, what this vehicle's been doing, how hard you're braking. I have a new Chevy. It actually rates you. I have an app that I don't like looking at, but the first time I drove the car, I got an 85%. It rated me, my driving. The second time I drove it, I got a 35%. So, of course, I'm thinking, well, what did I do to, give me that rating? And they actually track hard brakes, hard accelerations, hard turns. I don't know if they're, showing how straight I am on a line on GPS. Probably not that accurate. But, think about dongles. You know what a dongle is, right? It's a USB stick that's collecting data. Whether it transmits or not, I don't know. But, that is one of the most hackable things on the planet. In fact, that's, you go to any cybersecurity conference, that's what they do. They leave USB keys on the ground and hope that someone says, oh, hey, that's cool. I'll pick it up and I'll stick it in my computer. And wow, there's all kinds of great sound files on here. But yeah, it also just downloaded a virus on your machine, right? Also, where are these devices sourced from? Where are they coming from? Who's manufacturing them? Could be anybody. And they could put any kind of software they want on that firmware and that chip. Yeah, and as I mentioned, mobile auto software. They're connecting right to your phone, right? And phones are very hackable, okay? Vulnerable systems. What do all of these devices here have in common? Right. They're running some operating system. That in probably these cases, the ones that are broken into, they're probably vulnerable operating systems. I've heard stories, and maybe it's changed now, I'm sure, but Windows 95 machines, right, on these roadside units, right? And whether there's physical access to them or not, they are hackable, right? If they're networked and it's an older Windows operating system that's not hardened, Windows 95 is been end of life for a while. And interestingly enough, what the bad guys do is when an operating system like that gets near its end of life, if they find a security vulnerability, a lot of times they won't tell anybody about it until after the end of life period's over, and then the company's not supporting it anymore, and then they release all these vulnerabilities. So, yeah, it's a constant struggle. So, what are the safety, privacy, and security concerns? We talked about, a great increase in the number of devices, also the complexity of networks. Metcalfe's law, very famous, says that the connectivity of the network goes up of the square of the number of nodes that are connected. I'll argue that there's probably some formula for complexity, right? That's probably very similar, right? If you have n is 10, the complexity of that network is 100. You go up to 1,000, right? It goes up exponential. The types of connectivity. Now there's a lot of talk about 5G. And 5G's coming out. 5G's faster, right? Has all kinds of new capabilities, right? It used to be, back in the old days, we had 2 wires that connected everything, right? Twisted pair for phone lines. Now we've got, every kind of communication under the sun, near field communications, Wi-Fi, right, Bluetooth, on and on. And also the volume of information we talked about, but also the type of information that's being collected, right? So, we talk about vehicles, there's all kinds of telematics and all kinds of, different data points and sensors in those cars, right? It's, driving habits, it's braking habits. On the good side, this is all great stuff. It helps make things more efficient, reduce costs. On the bad side, it's all readable, controllable, and manipulatable, okay? And what is the result? So, in general, greater chance of being hacked. If there's more vulnerabilities, there's more access to get a hold of these things. Compromised safety, as we talked about, and privacy, okay? So what are the key challenges? Obviously, keeping safety and, human well-being as the highest priority. Managing these increased vulnerabilities, it's a big challenge. It's always a challenge for all of these big software manufacturers. Windows, the lines of code for an operating system go up, the vulnerabilities go up. So really the techniques and the mindsets have to change so that we can manage them, head them off, have really good proper testing. Maintaining privacy, and then also how do we intelligently manage this data deluge, right? What do we do with all this data? I've spoken to so many different major organizations, whether they be private companies or government agencies. They say, we've got so much data, we can't even throw it away fast enough, right? Major, Pennsylvania state agencies, they say 80% of their data they don't even look at because they can't, because it comes in too fast, okay? So let's talk a little bit about attack vectors. The controller area network, which is sort of the local network for the car. Any kind of pre-collision or sensing systems, or adaptive cruise control. Another algorithm that's in a vehicle. So this image here kind of gives you an idea of all the different things that and the newer capabilities that these automobiles have. Even self-parking, right? So self-parking, required that the steering wheel be electronically controlled and the braking, right? So that's an access point. Does anyone know what this orange piece is here? Does anyone all of you know what Telnet is? Okay, well, Telnet is basically a remote console technology. It's been around forever. It's also the most insecure remote communication technology out there. Well, it's a protocol, actually, right? Nothing's encrypted. You send a password. The password gets sent in clear text. But that Jeep Cherokee had Telnet not only open and accessible to anybody that could connect to it, but completely unprotected, right? Telnet is not even really widely used anymore. It shouldn't be. In fact, when we go in and do a cybersecurity assessment for any organization, if we see Telnet, we say just turn it off, right? There's secure shell, there's HTTPS, which is the encryption protocol for web traffic, right? So why would this vehicle have it? It's because in general, the producers of this technology are not cybersecurity experts, right? And should they be? Well, if they're not, then they should find someone who is. So yeah, this was an actual connection that they did. So they actually broke right into this vehicle through one of these, one of the wireless access points, right? So they didn't even have to plug anything into the car physically. They did it remotely. So just to give you an idea of sort of the range of different types of attacks, attack vectors, we kind of start with, there could be, more of the physical type of attack where you're actually, plugging something into a USB in the car, or, more remote attack, calling that indirect physical with Wi-Fi and pass-through. Can we actually get the car to change its firmware, right? So we could embed some of our own software in there, right? That would actually be probably one of the most serious things that we could do if we had some malicious code that was embedded right into the firmware of that vehicle, because it wasn't a trusted update. Like the car is not saying, hey, you're going to give me this update. Why should I trust you? Or trust that the software that you're giving me is what I should be running, right? This is another one that kind of scares me a little bit, sensor fooling, right? So, the driver, not only the driver, but Generally anything associated with that vehicle relies on those sensors more and more, right? Engine sensors, oxygen sensors, exhaust, CO2 sensors, all these kinds of things. If you can actually, change the value that that car thinks that sensor is, you've got big problems. Happened with 3 Mile Island, right? There was this remote sensor and there was some confusion as to what the state of that valve was, right? So what can be done? So how do we secure connected vehicles and transportation systems? Generally speaking, how do we secure any other digital system? The techniques that we would use are really the same. There might be some specific differences about, the individual technologies that we're securing, but, we use the same techniques. Cybersecurity best practices. All of these organizations, it's the manufacturer, the integrator, the government agencies that are, managing roadways, cybersecurity best practices. Common lists, common standards. Standardization is very important. The good thing is that from a cybersecurity perspective, standardization and techniques are pretty mature. If you went back to the 1990s, there wasn't anything because we didn't really need digital cybersecurity back then. But we've kind of been at it for long enough. We've got some good things in place, and we really just need to apply it to this vertical. So just to give you an idea of what some of these are, and these are somewhat in order as, from my perspective as far as the importance. Code review, right? So we've got software on a vehicle, whether it's in, the central processing unit there, any control system, maybe it's firmware and a sensor, right? If the manufacturers or the software developers from those manufacturers just, putting software together to make it work, right? And they don't look at, literally each line of code to see what vulnerabilities are there, there's going to be tons of them. In fact, software review wasn't a big thing up until, maybe 10 years ago, right? And now it's almost, if you don't do a software line-by-line review, you're going to get broken into, right? The fact of the matter is that, early software platforms were not built with cybersecurity in mind. So, for example, one known attack is it's called an injection, right? So if we've got a field or a variable that's, takes a name, let's say, we expect the name to be maybe tops 20 characters, 25 characters, right? Well, if that variable doesn't check, somebody could figure out a clever way to say, okay, well, I'm going to basically stuff, let's say a whole megabyte worth of data into that because I know that that variable sits right here in memory, right? And right over here in memory is a password, right? So if I inject that variable and that, the software doesn't check the variable length and say, oh, hey, wait, this is way bigger than I'm expecting, I'm going to get rid of it, I can basically actually put code right next to that password that executes and grabs me the password and sends it out the door. So that's just one example. If you do a code review, you actually can see that. You can go through and you say, oh, hey, this variable is not doing its checking. Okay, we'll fix that and put in some other control. Vulnerability management, patches, fixing vulnerabilities. Configuration management, how do we lock down this car and make sure that there's not something silly that makes it easily hackable. Authentication, you'd be surprised. Hard-coded passwords in code. Big security no-no, right? It's not changeable. Once somebody figures it out, game over, okay? PKI, public key encryption, identities of a vehicle or identity of a system makes it harder to hack and to fool it. Code review again. Things like virtualization and compartmentalization. That's a big cybersecurity technology that happens in phones. Most recently they'll take an application and kind of section it off from everything else. So, let's say this application's bad, it can't really, go laterally, they call it, or horizontally and break into other pieces of the phone, okay? And just general hardening. Trusted computing models, right? This is where, we've got some chip that is put in there, it's hardware, it's trusted. They've gone through the code, they understand what's in there. And we build layers and basically bootstrap the rest of the operating system, but it's tied to that piece of hardware that we trust. if you don't have that, any piece in that whole stack of software can be substituted and basically corrupted, right? Standardization, I won't go through all of these, but some of the groups that are either making standards, and consortiums of companies that are working together to basically enable V2X and autonomous connected vehicles, they all need to do cybersecurity. Some of them are, right? And if they're not, they need to. So let's move on a little bit to what we're doing. So I'm a professor at Harrisburg University. I started a startup out of Harrisburg University, and we deal with a new data format. It's called hybrid data. And what that is instead of having all of your applications on this side and all of your data on this side, which is pretty traditional and typical, we're basically trying to merge those two. So instead of having a Windows SQL Server dipping into a database and figuring all of the different connections out that are there, we're actually embedding a little piece of that logic into every piece of data. So what this does is allows us to create sort of an information layer over the internet, right? And there's been many discussions about this. There's all kinds of layers on the internet. There's communication layer, TCP, and communication protocols, and then HTTP or web traffic kind of sits on top of that. There's been a couple things that they've always said has been missing. One of them is sort of the financial layer, right? How do we securely exchange value across the internet, but also information, right? Because as it stands now, information is accessed, collected, processed by what? Silos, right? So we've got Facebook collects your data, they use it, they sell it, Google does it. That app you just installed on your phone, they've got a cloud storage, they're taking your data, right? But there's no general, overall sort of universal way of managing information. And with, all of the data that's happening now, there really needs to be something that can kind of work at the information layer. So what we've done is basically, you can think of the pieces of data that we're creating as sort of digital neurons, right? So what does a neuron do? It takes several inputs. We might say, your glucose level's high, you're tired, and some other condition, then the neuron says, okay, well, time to go to sleep, right? So we do that at each individual piece of data. So we might have a piece of data from a sensor, let's say. Maybe it's a temperature sensor. We can say, take the data that comes from this sensor. Is it, 30 degrees? Is it 50 degrees? Is it 110 degrees? We could put a little logic in that says, okay, well, if it's below 70 degrees or within 70 to 90 degrees, we're at a normal temperature range. If it's lower than that, we can say, okay, this is a low temperature range. If it's higher than that, we say higher. And then we can stamp that with sort of a pre-processed analytic. So in contrast, and control systems are getting more and more intelligent, and basically, there's a lot more analyzing happening, more towards the end, closer to the sensors. But we're trying to do sensing and analytics at each piece of data. So in an intelligent transportation system, you can almost kind of envision all of these different sensors and actuators and sources of information. If this is all of the raw data, our platform basically takes that data, processes it, secures it, and we can also embed basically any data model you want, right? And so, taking that further, within the last year, we've been doing a lot of research on how that applies to artificial intelligence, right? So if we could have a piece of data that says, hey, I'm a piece of data from a brake caliper, right? And I only should go to, the master cylinder, right? And it knows that if it goes anywhere else, that it shouldn't be there. I mean, even from a cybersecurity perspective, we've been asked to do, in the healthcare industry, protecting sensitive information, right? So we could actually have a piece of data, secured HIPAA data, health protected data that has a little piece of logic in it that is aware of where that data actually sits. So, we can put a rule in there and that says, I'm health information from this particular patient for this insurance company from this hospital. I belong in Pennsylvania. If I go outside of Pennsylvania, either, A, call the HIPAA police, B, self-destruct and delete yourself, right? Or really, anything along those same lines. So that's why we call this bottom-up AI. So, we think of top-down, bottom-up. Top-down is Watson generally, right? So you've got, a room full of supercomputers that basically have read all of Wikipedia and can beat a Jeopardy champion, right? Centralized, all the AI is self-contained in this cluster, right? So we sort of want to take a different approach where we're actually building that higher level functionality at sort of the byte level, right? So think of, little pieces of data that recognize each other, connect to each other, right? We can do all kinds of things with that. We can create neural networks, we can create Bayesian networks, we can do Markov models, okay? And three of the problems with artificial intelligence, some of them are actually pretty severe and significant. One's known as the black box problem, where I'm an AI engineer, I create this neural network, I have it in the system, I fire it up, I train it with a whole bunch of data, and then it spits out an answer. How did it get to that answer? Engineer says, no idea, okay? Because I just basically made a formula to create this complex network, but nobody can see the path through that network because it's too complex, okay? So one of the things that we can do is we can actually send tracers through. We have a piece of smart data that says, hey, I went through this whole thing and I came out the other end. I know where I was inside that neural network, and I can report that back to the developer and say, hey, here's how this works, right? Another big thing is training. How do we train artificial intelligence? You throw a whole bunch of cat pictures at it and hope you get the best. Training's very difficult, takes a long time. There's a lot of challenges with training. What if you didn't have to train? What if the data was already kind of part of the artificial intelligence system right from the get-go, right? So that's kind of where we're going with that. And certainly, from a privacy and transparency standpoint, artificial intelligence right now, there's no transparency whatsoever. And that's kind of the scary thing, even from an autonomous vehicle and where it drives and how it drives is, what algorithm is telling that vehicle where to go, right? What does it look like? How is that driving route based on feedback from me? When you're on Facebook and it serves you up an ad or a suggestion on who to connect to, how is it coming at that answer? You don't know, and they're not going to tell you, right? Because they're making money off of it. So, from a transparency standpoint, that's one of the things that we hope to do is say, hey, we're going to build these AI models and these data models, but the community is going to do it, or whatever entity that wants to build it. Here's our model, and we'll be able to show it. Here's the model. Here's how things work. Here's how things go in. Here's how things come out, and hopefully, we joke, save the world from Skynet, because everybody's kind of looking at this code and seeing what it does, right? So I think I'm a little bit out of time, so I'll take any questions if anyone has any. Right. Meetings based on what I know as a cybersecurity expert, like how do I do things differently? That's a great question. Certainly, the knowledge is probably difficult because it's like I know all this stuff is going on, and at some level I kind of, I do my best to really keep a low profile. Yeah, stay off Facebook. It's the amount of data and or Wi-Fi or anything. Yeah, I mean it's the less the digital world knows about you, the better. Until things get kind of sorted out. There's a GDPR in Europe, the General Data Protection regulations that have just come out, which is an amazing step because it basically says, on some level, citizens of the EU own their data. Right now in the U.S. we don't have that. In fact, we don't own our data. We click agreements that say, hey, I want to use this nice new shiny app, or, jump into this nice new shiny car, and when I first start up, I click and accept, and it says basically everything that happens belongs to some other entity upstream, right? So GDPR is a good step because it says, I own that data. If I want to get it deleted, I can get it deleted. So yeah, I mean, that's a big piece is, we should generally be pushing for those kinds of protections here. But, generally, change your passwords, don't go to bad sites, update your AV software, patch stuff. And if you don't trust something, or, even slightly, then don't do it. That would be my advice. Sir?
Do you see the increased use of secure code, writing secure code? Maybe there's a need for that.
Yeah. You mean generally like code that is actually kind of built to be secure? Yeah, certainly. There's all kinds of code resources that are, whether it's a platform or, some other plugin that can help with a lot of those best practices. But yeah, definitely, the level of security built within code is getting a lot better. I mean, old code, like even Java, older versions of Java, extremely insecure. So, but they're getting better. So yes.
I saw a recent story that just blew my mind. And it was there's a hackers convention. I forget the name of it. You probably know it. But recently,
DEF CON maybe.
DEF CON,
Yeah.
An 11-year-old and a 13-year-old in 30 minutes hacked.
Was that the voting system?
The voting system.
Yeah.
Yeah. So where are they getting this education? And I
Yeah.
don't know. I mean, what to do with that kind of information
Right.
at such a young age?
Yeah, it's a great point. Yeah, and it's kind of I draw the parallel to, I'm definitely showing my age, but first time I had a computer, I was 12 years old, right? And then these kids are growing up, literally born with some form of electronics in their hands, and it took me 5 years to get good at being cybersecurity, but it's resources, it's the internet, I mean, literally that information's all there, and they're so used to being around computers now. I think that's a big piece of it too, is that they're comfortable, with those types of interfaces. But I mean, yeah, smart kids though, or those systems are just grossly vulnerable, right? But it's both. So it's a great question. All right. Well, thank you, everybody.